Welcome back to our Chem 152 video series. In this video, we'll be finding the equilibrium constant and reaction coordinate for a reaction, and then we'll compare the two values. This question gives us 2 moles of NO2 gas in a 5-liter reaction vessel to start. Then after the reaction comes to equilibrium, the new concentrations are given as well. For part 1 of this question, we'll find the equilibrium constant K for this reaction. The equilibrium constant K is equal to the products divided by the reactants. However, we'll be using the equilibrium concentrations when we calculate K. Let's have a look at our equation. We have N2O4 as our first product. Our first reactant is NO2, but notice that we have 2 of them in the equation. Therefore, we write NO2 squared. Now, we place the equilibrium concentrations in each position. We are not quite looking at the information for the starting conditions yet. We're looking only at the equilibrium conditions. That is because we are doing equilibrium constant. Our concentration of N2O4 was 0.05. Our concentration of NO2 was 0.02. We'll put 0.02 on the bottom and square it. And then we can divide this in a calculator. Our answer for K will be 125. I will note this is not the actual K value for this reaction. These are numbers that I supplied specifically for this problem. So when you work this reaction in your own assignment, you're going to find a slightly different K value from this. Part 2 of this question asks us to find the reaction coordinate Q. Now, we're going to write Q similar to how we wrote K. The difference between Q and K is that rather than using the equilibrium conditions, we will be using the starting conditions instead. Our starting conditions are given in the first line of this problem. We're starting with 2 moles of NO2 in a 5-liter reaction vessel. Recall that concentration is moles divided by liters. We have 2 moles divided by 5 liters, giving us a concentration of 0.4 molarity when we divide. Notice that we have no starting information about N2O4. In chemistry, if we have no information about the starting amount of N2O4, we can safely assume there isn't any. Therefore, our starting N2O4 molarity will be 0. Based on this, we can calculate Q, which is again products over reactants. But instead of plugging in the equilibrium concentrations, we will just be using the starting concentrations instead, which were 0.4 and 0. Our product was N2O4. Our reactant was NO2. Again, because there are 2 of them in the reaction, we'll square this. So N2O4 is 0 over 0.4 squared. When we do the math, 0 divided by anything is 0. Therefore, our reaction coordinate is 0, while the K we found previously was 125. Now we will compare the values of Q and K to determine if the reaction proceeds forward or in reverse. Remember that our Q value was 0, our K value was 125, and we'll use the following guidelines to find which way the reaction proceeds. If the Q is greater than the K, we will react in reverse, also known as reacting left. If the Q is less than the K, that's the opposite, and we will react forward, or right. If Q happens to be equal to K, we're not going to react at all. The reason why we wouldn't react is that we would already be at equilibrium. Be careful about the word equilibrium. We oftentimes see the letters EQUIL and we think about equals. That's not necessarily what's happening here. Generally, when we are at equilibrium, that means the reaction is effectively finished. If you want to get technical, we can say that the rate that the reaction is going forward is exactly the same as the rate at which it's going in reverse. But in effect, we would not observe any reaction taking place. Effectively, for our purposes, the reaction is over. Let's compare RQ and RK. RQ is 0, and RK is 125. We can definitely see that Q is less than K here. Therefore, because Q is less than K, this reaction would go forward. We react from left to right. Keep in mind that generally, anytime Q is 0, you will be reacting from left to right. If Q was higher than K, we would have reacted left. Thank you all for watching. We'll see you again soon.